All right, hi, and welcome to this podcast style conversation we're having here today. I'm Cami Williams, and I'm a project specialist from TTAC William and Mary, and I have my colleague here today.
Hi, my name is LaShawna Britt, and I'm also a project specialist at William and Mary TTAC.
And today we're going to have a conversation focusing on word problem solving. We're delighted to have with us Sarah Powell from the University of Texas at Austin. So, Sarah, can you tell us a little bit about word problems and why word problem solving is important?
Yeah, sure, Cami and Lashana. So, word problems are often how students show their math knowledge. So, if you look at the Virginia SOLs, especially the tests that students take most often in the spring, on all of those math tests, it's almost all word problems. And so, students have to be able to read these problems and then use their mathematics knowledge to answer these problems. And there's two different types of word problems that we see really often. We see word problems that give a direction to do something. So maybe the question says, find all the shapes that are quadrilaterals. But there's also a lot of word problems, the ones that we should talk about today that are harder for students. They also have a text that students have to read, and they have to then grab numbers from that problem and manipulate those numbers to answer a question that's in the word problem.
So, Dr. Powell, we hear from a lot of teachers in the field about how word problems are tricky for their students. Can you explain a little bit why the word problems are so tricky for students?
Yeah, Lashana. So word problems are tricky for students because there's multiple steps that students have to do to solve the problem. So for example, students have to read the problem and they have to interpret the vocabulary in the problem. So they have to figure out, well, what is this information that I'm reading and what do I have to figure out? Students have to identify which numbers in the problem they're going to use. And many times they also have to identify which numbers they're going to ignore, what is irrelevant information. A lot of times in word problems, there are charts or graphs that students have to interpret. So that's another area of difficulty for students. And then finally, students have to figure out, well, what am I going to do here? Do I want to add, subtract, multiply, divide? Do I want to do a few of those things? So they have to figure out, which operation or operations they're going to use. And then finally, they have to do that math. So because there are so many steps to solving a word problem, that's what makes it really difficult for students.
Right, we see that often in our coaching when we go out to different classrooms. So, what does word problem solving look like in the classroom?
So, in most classrooms, a lot of teachers will use some type of what we call a cognitive strategy that helps a student work through the steps of a problem. So, one of the cognitive strategies we see used a lot in classrooms is UPS check. So, that's understand the problem, make a plan, solve the problem, and check your work. Another one that we'll see a lot in classrooms is called cubes, where students do each step of CUBES to solve the problem. There are lots of different cognitive strategies, and most teachers will use those. Another thing that we see in classrooms that teachers do, which is really not the greatest strategy to use, is they teach students to identify keywords and they link those keywords to an operation. So they might say, oh, whenever you see share in a problem, that means you're going to divide. Or whenever you see total, that means you're going to add. That's actually a really ineffective strategy. We've just done a research study that shows that in single step word problems, that strategy only works about 30 to 60% of the time. And with multi step word problems, which is really what most students are solving in the late elementary grades and in middle school, keywords work less than 10% of the time. So, we see some good practices in classrooms, and then we see some ineffective practices in classrooms.
Okay, so, well, if it's not a good word problem strategy, what is it?
Well, first, I'd like to really focus on two things that we know that are effective. And that is having an attack strategy. You can kind of think about that as your cognitive strategy. And then combining that with a focus on the word problem schemas. That attack strategy helps guide the student through every step of the word problem process. And then the schema is going to help them really understand the deep meaning of that word problem.
So, does it matter which attack strategy a teacher uses?
No, it really doesn't. I always tell teachers that I don't care which attack strategy you use. There are so many out there. So I already talked about UPS check. I mentioned cubes. There are attack strategies called star or ridges or ride. And there's a lot of attack strategies that don't have a mnemonic that's hooked with them. So I always say, I don't care which attack strategy you use. I just care that you use one and you use it every time you, the teacher, model solving a word problem to your students and every time you engage your students in word problem practice. So just choose one and then use it regularly. That's every day of the school year, anytime you're solving a math word problem.
Okay. So what's the second strategy that has a strong evidence base?
Yeah, so that second one is that focus on schemas. So a schema is the deep structure, or sometimes people call those the problem type of the word problem. And the nice thing about a schema is that there's not that many of them. So once students learn the different schemas, they can say, oh, this word problem, that's an equal groups problem, or this problem, it's a total problem. So students can read a word problem and recognize that they haven't solved this problem before, but they can recognize, oh, this is really similar to all these other types of word problems. So what's really cool about schemas is that they can use knowledge to solve many problems by understanding just a few different schemas.
That's very interesting, Sarah. So again, like I said, LaShawn and I work with teachers out in the classroom coaching, and we've seen where teachers have used the keyword strategy.
Mm-hmm.
So for those that are listening that may use the keyword strategy or and have recognized that it's not as effective as they were hoping, and they're looking and interested in the idea of schemas, what's the research behind schemas?
So there's a lot of research behind schemas and not just in education. So one of the strong evidence base or research bases related to schemas comes from psychology and basically how people learn things. So they say that, and this is not just math related, this is really overall, but there's a lot of research from psychology that says that as humans, we typically organize our knowledge into schemas. You know, here's how I cook in the kitchen, or here's how I do my laundry. And you have a schema for organizing that information. And those are just kind of some basic examples there. But in general education, there's a really large research base around schemas. And much of that is through what they call cognitively guided instruction. So that's an effort led by Tom Carpenter and a lot of his colleagues, but it's how to help students organize their knowledge related to the operations. So how do they understand adding, subtracting, multiplying, and dividing? And then how does that relate to the word problems that we see where students add, subtract, multiply, and divide? But really importantly, there's a very large research base about schema word problem instruction in special education. Researchers have been investigating this for the last 10 or 20 years. And we know time and time again that when teachers implement schema instruction with students who either have a disability or who experience difficulty with mathematics, that will improve their word problem outcomes. So we see the research from, just general psychology, we see it in general education, and then really importantly, we see it in special education as well.
And these schemas seem really important. Is there like a specific amount? How many schemas does a student have to learn or should learn?
Yeah, that's great. So there's not that many. There are really 6 that we see used regularly across grades K through 8. There are 3 that are typically introduced or learned around kindergarten. And then those will continue with us for the rest of our school career. So one of the ones that we learn in kindergarten is the total schema, where we have parts that are put together for a total. So I might say, Lashana has $5, Cami has $4. How much money do they have together? I'm putting your money together. The second schema that we see introduced in kindergarten is the difference schema. Some people call this the compare schema as well. And in the difference schema, we're comparing amounts. So I might say, Sarah has $12, Cami has $6. how much more money does Sarah have than Cami? So we're comparing our amounts of money. And then the third schema that we see introduced in kindergarten is what we call the change schema. And there can be a change where we have an increase or a change problem where we have a decrease.
Mhm.
So I might say, Lashana has, or let's say Lashana baked 5 cookies and then she baked 10 more cookies. How many cookies does Lashana have now? So we can see an increase in your number of cookies. I could also say Lashana baked 20 cookies and then she ate 2 of them. How many cookies does Lashana have now? So there we see a decrease in your cookies. So in the real early elementary grades, we see those 3 problem schemas, total, difference, and change. Now, starting in 3rd grade, we see the introduction of 2 more schemas. So this is as we transition from learning only about addition and subtraction to now learning more about multiplication and division. So the first multiplication division schema that students will learn is called the equal group schema. That's where we have groups with an equal number in each group. So maybe I think that I have 3 mugs with 10 pencils in each mug. So how many pencils would I have altogether? We also have the comparison schema. So here's where we have a set that we multiply a number of times. So I might say, Cami read 5 books over the summer. Lashana read 3 times as many books as Cami. So how many books did Lashana read? So there I'm thinking about multiplying that set of, I think I said 5 books over the summer, you multiply that 3 times. So, and then once you learn those stick with you for pretty much the rest of your life. And then starting in middle school, we introduced that 6th schema. And that schema is related to thinking about the relationships within ratios or proportions. So once that 6th schema is introduced, students pretty much have a really strong schema knowledge. But if you are a middle school teacher, you can't just introduce the ratios or proportion schema. You have to do the total, difference, change, equal groups, and comparison, because most often in middle school, we'll see that students have to solve multi-step, multi-schema word problems, where maybe first they have to figure out the equal groups and then they have to figure out the difference. Or maybe first they have to figure out the total and then they have to figure out the change. And so as students move across grade levels, their schema knowledge accrues, but most students have pretty strong schema knowledge, or they should have it by the time they get to middle school.
I'm really glad you brought up the multi-step piece to that, because
Yeah.
especially in secondary, that is an area where we find that teachers have students that struggle the most in the classroom. So with our listeners in mind who would like to introduce schemas, understanding that it could help with those multi-step problems,
Yeah.
how would a teacher teach their students about the schemas?
Good question. So the first thing is to teach what a schema means. And typically we do this in isolation. So you'll want to spend maybe 1 to 3 of your class sessions only talking about the change schema or only talking about the comparison schema. Introducing it with stories. Sometimes we introduce them without numbers. That's what they call a numberless word problem, just so that students can understand, oh, in this different story, you're comparing Cami to Lashana, and here's what that comparison is. We do a lot of stuff with visuals during this time. You might do drawings, you might use manipulatives, either hands-on tools or virtual manipulatives, to really help students understand, well, what does it mean if we put amounts together? That would be the total schema. And how does that differ from the different schema when we compare amounts? And then once students recognize a word problem that belongs to a schema, it's important to teach them what we call a solution strategy. So a way to figure out the solution to the word problem. 2 of the really common solution strategies are to use a graphic organizer. So is there a graphic organizer that represents this schema? As soon as I figure out that this problem belongs to this schema, I can use that graphic organizer, fill in the information from the word problem, and move on. And the second way is to use equations. So to use an equation that represents each schema. And then third, really paying attention to the vocabulary within the schemas. But you want to make sure that you don't link it, like don't I just identify those keywords. But in a word problem where if I say, Cami read 5 books and Lashana read 3 times as many books as Cami. Well, that 3 times as many, that's really important there. What does that tell me? Does that tell me that Lashana is going to have read more books than Cami or fewer books than Cami? If it's times as many, does that tell me that I'm going to be adding or maybe I'm going to multiply? And so really having some deep discussions of what the text is within that word problem and being able to pick out parts. Like if I say that, Cami has $6 more than Sarah, well, that's like really important to focus on, right? So if she has more dollars than I have, then her amount is going to be greater. And what does that actually tell us for the schema and for how we're going to solve that word problem? So teach what the schema means, teach a solution strategy, and then really dig deep into that vocabulary of math so that students can interpret what that word problem means at a deep level.
Wow, that's a lot of helpful information. It seems like it would take a lot of a lot of time to help students understand these schemas. So
Yeah.
what's one thing a teacher could do to start this word problem solving tomorrow?
That's a great question, Lashana. Well, the first thing you do is get an attack strategy in place. So look at the word problems that your students regularly set up and solve. And how do you want them to work through those word problems? At the beginning, I said, one of my favorite attack strategies is UPS check. You understand the problem by reading it, you make a plan, you solve the problem, and you go back and check your work. That's a really good attack strategy that can be used across lots of different word problems in different grade levels as well. So look at the other attack strategies that are out there, choose your attack strategy and start using it tomorrow. That's a pretty easy way to start to focus on effective word problem solving.
So that takes care of what they could do tomorrow. What could a teacher do over the next few months to help with the word problem solving in their students?
So that's where I would suggest layering that instruction on the schemas on top of that attack strategy. So maybe you introduce the attack strategy and you practice it for a week or 2 weeks or for a month just to get your students into using the attack strategy. Because probably if your students are anything like a lot of the students I work with, most students don't read the problem first, they don't make a plan, and they don't really know how to attack the word problem. So get the attack strategy in place. And then over the next few months, slowly start to introduce those schemas. You can't introduce all the schemas in 1 week. That would just be information overload. I would typically suggest maybe focusing on a schema for 1 or 2 weeks. So maybe first introduce the total schema, practice that schema, then introduce maybe the change schema or the difference schema. And then once you introduce a second schema, go back and forth and say, okay, let's read some problems today. Is this a total problem or is this a change problem? To really help students discriminate between, oh, well, in that problem, they're putting amounts together. And in this problem, it's increasing or decreasing. And then introduce the third schema. So maybe every few weeks over the next few months, introduce a new schema, practice it in isolation, and then practice it with the other schemas that the students have learned.
Okay. So Sarah, we may have a lot of school administrators that are listening or watching this. Do you have any suggestions on how they might support this schema-based instruction in their classrooms?
Yes, I do have some suggestions here. So, one thing that's going to be really important is thinking as a school, how are you teaching word problem solving? Every classroom teacher can be doing their own thing, but it's going to be better for students and also easier for teachers if the school thinks about how they teach word problem solving so that as students move from one grade level to the next, it's kind of a seamless transition in terms of problem solving. And also as students move from maybe general education to special education, or they have, received some math instruction in a resource setting and some math instruction in a gen ed setting, it would be really nice if those teachers were doing the same thing. So first I would suggest for an administrator to really think about a few times a year where teachers can get together across grade levels and also gen ed teachers and special ed teachers or gen ed teachers and math intervention interventionists, where they could have a planning time where they sit down and they say, okay, what are the word problems that our students are asked to solve at this grade level or across grade levels? And what are some of the ways that we could teach that? So I would really encourage administrators to, ask teacher groups or ask all of the teachers who teach math in a school, all right, what's the attack strategy that our school is going to use? So if you walk into every math classroom in that school, you see the same attack strategy poster. I would also encourage administrators to seek out professional learning opportunities so that teachers can deep dive into those schemas. And then thinking about giving teachers time to talk about, okay, well, what are the schemas we're going to focus on at each grade level? How are we going to describe those? What is our problem solution going to be? Is it going to be graphic organizers or equations? So I think just really carving out some time where the math teachers in the school can come up with an effective word problem plan.
Sarah, you just got me really excited hearing that. I love the idea of creating that continuity, not only for the teachers, but also for the student. I think that would definitely help the word problem solving and the schemas and the attack strategy
For
to have
sure.
an impact
Yeah.
on those students. And I think that's an awesome idea for administrators to support their teachers. So you've given us a lot of great information. Are there any resources that you would suggest that are out there about word problem solving?
Well, this past summer 2020, I did some work with you all and the William and Mary TTAC, and we recorded those webinars. So I hope that people could watch those webinars and really learn, get in deep dive into the additive or the addition and subtraction schemas, the multiplication and division schemas, and the multi-step problem solving. One of the things that I've worked on over the last few years is with the National Center for Intensive Intervention, which their website is intensiveintervention.org. And there we developed a bunch of modules about how to develop and deliver math intervention. And in one of those modules, it's module 5, part 2, there's about an hour video that I helped create that gets into all the attack strategies and all of these word problem schemas. And that's a free resource that anyone can access at any time. So if you visit intensiveintervention.org, you will be able to find that math intensive intervention course. And then finally, my research team and I do a lot of research in this area, and we've just finished development of, it's intended for third grade, but it would work for second graders and probably all the way up to fifth graders who experience difficulty with math. We've developed a word problem intervention that's totally free. All the materials are available for teachers to download. That program is called Pirate Math Equation Quest. It's kind of a long title. And if you visit the website piratemathequationquest.com, teachers can download, there's an individual tutoring program and there's a small group tutoring program. They can download all the lesson guides and all the materials and all of the graphs and flashcards and everything that students would use in that program. All of it's free, and teachers can also get that information, and it has the attack strategy and the schema. So everything is right there, all combined nicely for teachers.
That's so awesome. I feel like we were just on a TV show and you said, check under your chairs. That is
Yeah.
awesome.
Yeah. So we're really excited about it. So we hope that teachers will access that, the Pirate Math Equation Quest materials, and use those with their students.
Well, I'm also very excited, and thank you
Great.
for joining us, Sarah, and talking about word problem solving.
All right. Thanks, Lashana. Thanks, Cami.
All right, thank you.